Okay, welcome to the 7th lesson in the linear algebra and modeling sequence. This is called inverting the problem, inverting the matrix. So previously we found a point that satisfied two lines. It was the intersection between those two lines. It was the set of values that was a solution to both equations defining the lines. So what if we want to find a line that connects two points? For example, we might take the points -3, 4, and 2, -3. And here, let's plot those using R. And here you see this, and you can probably look at them and see the line. You know, it's something like that. It's actually pretty good. But what we want is an exact solution. So we're going to use linear algebra to find a function that fits both of these points. So we know that the equation is going to look something like this. So we're going to have beta 0 plus beta 1 times x sub I is equal to y sub I. Now, there's a lot of new notation here. So let's talk about what's going on before we move on. So beta 0 is going to be the y-intercept. And beta 1 is going to be the slope. Now, why do I have this little I here for x and y? That's because it's going to go along with an instance from our data set. We have 2 points in our data set, so we want x sub I for a very, the first one might be x sub 1, y sub 1. And the second one might be x sub 2, y sub 2. And we're going to see this notation a lot as we go forward. This is sort of the notation that we use when we're talking about a general instance from the data set. So we're going to call it x sub I, y sub I. This is the equation that's going to work for this line. Now I can rewrite this. I can rewrite this as 1 times beta 0 plus x times beta 1, x sub I, is equal to y sub I. Now, you should notice that this is a dot product. You know, I want you to start to be comfortable with this, comfortable with the idea of dot products and looking at things and spotting a dot product when you see one. So let's rewrite it using dot product notation. We're going to call it 1 comma x sub I transpose times, and this is a vector with 1 and x sub I as the values in the vector, times beta 0, beta 1, and this is the dot product, is going to be equal to y sub I. And I'm even going to rewrite this one more time. I'm going to write it as a row vector, 1 x sub I, times a column vector, beta 0, beta 1. And that's going to be equal to y sub I. Now what we can do is we can take this and we can combine it with the points that we have previously. So if I take this first form, I would have 1, -3 transpose times beta 0, beta 1 is equal to 4. And this is actually the second point, but that's fine. We're going to have 2 equations, 2 points. It's fine. And then we're going to have 1, 2 transpose times the same values, beta 0, beta 1, is equal to -3. Now have a look at this right here. I want you to think about, what are the unknowns? What are the unknowns here? So previously, the unknowns were the x and the y. We were trying to find the x values. But now we're not trying to find the x values. Now we're trying to find the slope and the intercept. We're trying to find these these coefficients that are going to define the equation. So what I can do with this, so if we convert this, and we've got 1 -3 times beta 0 beta 1 is equal to 4, and 1 2 times beta 0 beta 1 is equal to -3. Now it's just another step to convert it into our matrix form here. So I've got beta 0, this is another way of writing it. Beta 0 times 1, 1, plus beta 1 times -3, 2 is equal to 4, -3. Or here we've got it in this matrix form. We've got a matrix 1, 1, -3, 2 times the vector beta 0, beta 1 is equal to 4, -3. And this is useful because we're just going to think about it like this. We don't want to think about all that bookkeeping up above with all these numbers and everything. We're going to let R handle that for us. All we want is X times beta equals Y, where X is a matrix containing this column of ones and then a column of our X values, and Y is a column of our Y values. So we've been talking about the inverse, like the inverse matrix, and this is just quick review about what's going on with the inverse matrix. So it is important to know that the inverse does not always exist. So I've got it right here. For some matrices, an inverse operation exists. It doesn't exist for all of them. So the way that you should think about this is, if we have two matrices, say A times B is equal to C, then we could say that B is equal to A inverse C. So one way to think about this is, we're taking this matrix B and we're transforming it by multiplying A times B, and we wind up with a new matrix C. Now, if we want to change C back into B, we multiply A inverse into C, and we get back to B. Now, one other thing that's important to note is that matrix multiplication is not commutative. Everything we've seen so far has been commutative. Matrix multiplication is not. So the matrix A times the matrix B is not equal to the matrix B times the matrix A. I mean, there could be some cases where it would be true, but in general, it is not true. Okay, so we want to solve this system here. We have X beta equals Y. And remember that X was going to be a column of ones, and then our X values. And beta was the thing that we don't know. And Y was a column of the Y values. And we want to know this. And of course, we can use the R function solve to get this for us, because we know that beta is going to be equal to X inverse Y. So if I'm looking at this X beta equals Y here, I could multiply X inverse to both sides. And this is the identity. And the identity times beta is just beta. So this is what we want to solve right here. And this is going to give us these coefficients. It's going to give us the intercept and the slope, beta 0 and beta 1. All right, so in order to solve this, I'm going to define X first, and I'm using the R function rbind, or row bind, to do this. And I'm passing it 2 rows. I'm passing it the first row, 1, -3, and the second row, 1, 2, as vectors. And it's going to turn that into a matrix. an X matrix using this row bind function, rbind, and then Y is going to be the vector for -3. So we define X and Y. Here's X, and it's what we expect. Now we can find beta by just doing the solve. And there it is. These are the betas that we're looking for. These are the betas that are going to work for those 2 points. And let's plot them. Now this is a little bit tricky how I'm doing the plot. I'm making a line here, which is going to be XX. And then this goes back to the very first lesson where we were drawing, we were doing linear combinations to make new vectors. We're going to do beta 1 plus beta 2 times XX. And there's that line. Now, I will say there's one little tricky thing right here, and it's this, beta 1 plus beta 2. Now, in most of the literature, it's going to be, the equation is going to be of the form y equals beta 0 plus beta 1 x. So in ISLR, that's how they're going to look at it. The intercept is going to be beta 0, and the coefficient of x is going to be beta 1. But here in R is indexed from 1. So we can't have, these numbers here are the indices. So it's just, I don't know, it's just a little tricky thing to keep in mind. Yeah.